I want to know more about the work that you're doing. The coronavirus.
Okay. No. It's been interesting. So like, what have I been? So when you develop a vaccine, like I was saying earlier, the points of contact are, so you can imagine a normal virus and then it's got the spikes coming off of it. We've all seen a picture of it.
Yeah.
And so when the spikes touch its target cell, that's basically where all the activity happens. Okay. So if you want to try and make a vaccine, you've got to try and really find out as much as you can about the surface of the virus. And so like the problem with the coronavirus that's like makes it quite different to a lot of viruses is that they're like snowflakes.
Yeah.
So like every single one is different, and it means that you can't make a one vaccine fits all.
Yeah.
For like
everything. It always mutates, doesn't it?
They all look different, and they always mutate. They mutate from country to country, even from area to area.
Even weather, like the humidity could influence the virus.
Definitely. Even if it's passed through like a farm before it's passed to someone else, or it's passed through someone who has pets or not, it can really make a difference, because it's about what kind of person or animal or whatever holds the virus before it's passed on to you. Yeah. So so that's why it's really difficult to map, and it attaches onto a lot of different molecules in your body, so it's quite hard to detect anyways by your antibodies. So with all that, it mutates a lot. Your antibodies can't really keep up, and they all look really dissimilar as well. So how can you begin to start finding the structure? And you start to do that by there's this thing called electron microscopy. So the field is called tomography, and it's basically the method of imaging viruses. Mm-hmm. And so with other viruses, because they're similar, you can kind of splice images together, piece them apart, and then kind of make a 3D structure that can be used then to develop the vaccine. But you can't do that with the coronavirus. And there's no way to kind of process large amounts of data really quickly to kind of get a sample of what different coronaviruses could look like. So a person has to manually look at each picture, count the spikes, identify each spike, and because they're all different, that would take forever. And so it would not be efficient at all. Mm-hmm. And so no one's kind of done this kind of automated process before on the coronavirus. It's been done by one person on HIV in America, but the HIV virus, again, is a bit different from the coronavirus, because the coronavirus is called the coronavirus because of the coronas, which are the kind of meteor-like bumps which appear on the surface, mm-hmm. which make them not symmetrical. So it means that you have to basically play around with a load of different imaging techniques and kind of isolate what the virus spikes would look like. Mm-hmm. And then by doing that and processing those images, you can find out the proportion of each spike, how big they are, how thick they are, all these kind of things. And then that's how you make a good vaccine, and that's what I've been doing.
That's fucking sick, and that is definitely going to be a highlight.